Hello and welcome to my channel. I am Untitled. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and not yet subscribed, please kindly subscribe for us to build a mathematics community. In this lesson, we'll be looking at the intuitive notion of continuity of a given function. Thanks to Ali from University of Legon for requesting for video on continuity of functions. So now we are going to use our intuition. So here we will not do math proofs, but in our next lesson you look at continuity of a function in more vigorous way using some proofs. Now let's use our intuition. If we take p of x equal to an x exponent n minus 1 plus an minus 1 x exponent n minus 2 plus ax plus a naught. This is a polynomial function. This is a polynomial function. So we are saying that a polynomial function is defined everywhere. That is, it is continuous everywhere. It is continuous everywhere. So, example of a polynomial function, let me take f of x to be equal to 3x cubed minus 4x squared plus x plus 1. This is a polynomial function. This is a polynomial function. Now, if I take, let's say, f of x is equal to 7x squared minus 12 to the power 10. This is also a polynomial function because we have a polynomial function multiplying itself 10 times. So you still get a polynomial function. You still get a polynomial function. So let's say f of x is equal to 7x cubed minus 4x squared plus x to the power 5 minus 1. Let me raise it to the power, let's say 14. It is still a polynomial function because here a polynomial function is multiplying itself 14 times. So a polynomial times a polynomial will give you a polynomial. It will not give you an exponential function. It will not give you a trigonometric function. It will not give you a logarithmic function. It will still give you a polynomial function. So this function is continuous everywhere. This is also continuous everywhere. This is also continuous everywhere. And what is the interval of continuity? The interval of continuity is from negative infinity to positive infinity. Why are we stating that? It is from negative infinity to positive infinity. That is, if you take any real number, either it is a fraction, either it is a decimal, either it is negative, or either it is positive, and you substitute it here. So guess any number. Let me guess any other number. Let me guess negative 200. I'm going to use this. Let us take the limit of 7x squared minus 12 to the power 10 as x approaches negative 200. Wow. As x approaches negative 200. And then check and see that f of negative 200 will also be the same as this. So let's check and see. So here we are going to take the limit of 7x squared minus 12 to the power 10 as x approaches negative 200. Wow. Very simple as that. So it's a polynomial function. Now let's move on. So this will give us 7 times minus 200 squared minus 12 all to the power 10. And if we take the calculator, 7 times minus 200 squared minus 12 all squared, wow, will give us a very big number, 7.8 times 10 exponent 10. Wow. Now let's find f of minus 200 and c. If we take f of minus 200, we are considering this one. Whenever we see x, we put minus 200. So we are going to get 7 times minus 200 minus 12 to the power 10. And you see that what we have here is the same thing as what we have here. So our answer is going to be approximately 7.8 times 10 to the power 10, as we've had here. You can guess of any other number. You can take this one, guess of anything. Let's say take this and take 20. Take the limit as f of x approaches 20. And then find f of 20 for this. You see that the answer will be the same. So that is why we are saying that polynomial functions are continuous everywhere. And their interval of continuity is from negative infinity to positive infinity if we are considering set of real numbers. And in fact, we are dealing with real numbers here, not complex numbers. Wow. Now let's move on. So we conclude that for every polynomial function, the interval of continuity is from negative infinity to positive infinity for set of real numbers. So set of real numbers from negative infinity to positive infinity. And we state that polynomial functions are continuous everywhere. Now, let's take a rational function. A rational function is the form f of x divided by g of x, where g of x is not equal to 0. Now, we've been studying limits up to this time. So once you've been studying limits up to this time, you should have come across rational functions as we are studying limits. And we said that if we have f of x divided by g of x, where g of x is equal to 0, then it means that this one is undefined. That is, does not exist. In terms of limit, you say it doesn't exist. But in terms of normal rational function, you say it is not defined or is undefined. But for limit, you say does not exist. So let's take our first example. If we take 5x squared minus 4x minus 1 divided by x minus 2. Here, is this function continuous? Let's discuss the continuity of this function, right? Now, you say that what is at the top is a polynomial function. So for the top, since it is polynomial, it is continuous everywhere. If you consider the denominator alone, if you consider x minus 2 is a polynomial function. So it is also continuous everywhere. But if we are considering the rational function, our main point of consideration should be the denominator. If we are talking about a point of continuity. So you see that we are saying that for a rational function, if the denominator is equal to 0, then we are saying it is undefined. And for limit, you say the limit does not exist. That is indeterminate form. So now, for this function to be continuous, then it means that the denominator, x minus 2, should not be equal to 0. The entire denominator should not be equal to 0. So this function is continuum on its domain. You do domain of functions and you get to understand what we mean by the domain of the function. So here, x minus 2 is continuous, except that if we take x minus 2 equal to 0, there is going to be a breakage in the curve. There's going to be a breakage in the curve. Sorry, in the graph of this function. So we are saying that this function is discontinuous for x equal to 2. We equate the denominator to 0 and we get x equal to 2 for real numbers. So we are saying that this function, I will say it is discontinuous. discontinuous. DCT for discontinuous. Okay, let me do it N so that we get the term. So this function is discontinuous at x equal to 2, because if you put x equal to 2, 2 minus 2 will be 0, and we will have 5x squared minus 4x minus 1 divided by 0, which does not exist in terms of limit. And for rational functions, see, this is what? Undefined. So if you draw the graph of this function, there will be a hole, there will be a breakage. Because for a function to be continuous, when you are drawing the graph of the function, you will not remove your pencil or your pen. Look at this. This is a continuous line. But if I draw this line, this is not a continuous line because I removed my pencil and there's a hole here. Very simple as that. So a continuous function is like throwing a ball. Have you seen? If I throw this duster, you see that it will move this way. Very simple as that. So this function is discontinuous at x equal to 2, because at x equal to 2, the denominator will be 0 and you have a hole in the graph of this function. Now watch as I reveal more secrets here. So what will be the next example? Let's look at the next example and see where we are going to. Now, before we look at the next example, let's look at the interval of continuity of this function. You see that we cannot take x equal to 2. We can't take x equal to 2. But for any value, apart from these two, the function will still be defined. So watch here very carefully. Let's say that we take x equal to -1. If we put here -1 minus 2 will be -3, and the denominator will not be equal to 0. So you see that this 2 is not part. So here we can take any value from -infinity, but 2 is not part. If you have not watched my video on interval notation, check that video for interval notation. You see that this parenthesis bracket means that the endpoint is not included. So since we cannot take 2, we will do this. But it is not only negative numbers. Positive numbers can also fill in the space apart from positive 2. So we take union 2 add to positive infinity. So this will be the interval of what? Continuity of this function. Meaning that these 2 cannot be included. Very simple as that. So if you don't understand this, just check my video on interval notation. We said that we can take any number, any positive number, apart from 2. So here 2 is not included, but we can take any positive number up to infinity. We can also take any negative number, so negative infinity, but we can't take 2. So we combine this to become union. So the endpoint here, the parenthesis bracket means that the endpoints are not included. So watch my video on interval notation from the description. Now, let's take another example on the same rational function, but with different idea. Let us take this one. I have 3x squared minus 5x plus 1 divided by x squared plus 5. Let us discuss the continuity of this function intuitively. We are not going to take any limit and any other thing. Now, from our intuition, rational functions are continuous except when the denominator is equal to 0. So first, if we look at this function, it is a polynomial function, so we don't have any problem with the polynomial. Any value that you put there, this one will be continuous. But here we have x squared plus 5. We are dealing with real numbers. So you see that if we equate this to 0, you have x squared equal to -5. And x will be equal to plus or minus the square root of -5. Which does not exist under set of real numbers, because square root of negative 5 will give us a complex number, but here we are talking about real numbers. So here we are not going to look at this. We want values that will make x squared plus 5 to be 0. And if we consider real numbers from negative infinity to positive infinity, any number that you put here will not make this one equal to 0 because of the square that we have here. Ali, I hope you are getting it. Yes, I hope I have Ali, Rosina, Alupak, and then Bohem. Yes, Ebenezer Bohem at University of Ghana. If you are watching this video, look at this very well. You see that this x is squared. So let's say that if I put in x equal to negative 5, it will be squared plus 5, and I'll get positive 25 plus 5. Wow. So any value from negative infinity to positive infinity, this function will still be continuous. So we say that this function is continuous everywhere. It's continuous everywhere. And the interval of continuity from negative infinity to positive infinity. So if you hear that rational functions are continuous, except that when the denominator is equal to 0, don't go and say that this is not continuous. This is continuous when we are talking about real numbers. When we are talking about real numbers. So this is for real numbers, this function is continuous, and the interval of continuity is from negative infinity to positive infinity because of the square that we have there. Now, let's move on. Let's take another example. With regards to this one, I'm going to take, let's say, 7x minus 2 divided by x cubed plus 5. What about this one? Here, the only difference is that here we have even number. Remember that we don't have square root of, we don't have radical. If the number is negative, this is what I want to say. Let me put it down. Let's say 5. You see that this is an even power. Let's say that this is to the power 1 out of 2 will give you square root of negative 5. So if I write minus 5 to the power 1 out of 4, this will give you 4th root of minus 5. So if the radical is even, this is an even radical, 4th root, and we have negative there, we will be going to complex numbers. So these ones are off. So if you get something like this, so if here is to be power 4, it is continuous everywhere. If here is power 6, it is continuous everywhere because of the positive sign. After this one, I'll do the one containing negative sign. Okay, so here we have x cubed. X is not an 3 is not an even number, so we can equate this to 0. We are going to have x cubed plus 5 equal to 0, and you have x cubed equal to cube root of minus 5. Oh, let me do it step by step. Minus 5, and I have x equal to the cube root of minus 5. Wow. And the cube root of minus 5 is defined the same as minus cube root of 5. So it is defined. Very, very simple as that. So this function is continuous on its domain. Thus, it is continuous everywhere except at x equal to this. So the function is discontinuous at x equal to negative cube root of what? 5. Or you can say cube root of minus 5. So at this point, there will be a hole in this what? Graph. Very simple as that. So here, if you have positive sign here, and you take odd powers, let's say 7 is an odd power, you still have x is discontinuous at, the function is discontinuous at x equal to negative 7th root of what? 5. Very simple like that. So that is the difference between even power if we have plus, and then even power, odd power if it is plus. Let's check if what is here is subtraction. So for instance, so we say this function is discontinuous at x equal to negative cube root of 5, or you can say x equal to cube root of minus 5, the same thing. Now let us take the same thing. Let's say 5x cube minus 2x plus 1 divided by x to the power 2. Let's take 4. It's an even power, minus 5. Here, since here is negative, we are not going to say it is continuous everywhere, except it is continuous everywhere. Now, let's look at this. This one, I didn't write the interval of continuity of this one when I made here 3. Let me do that one. When I made here x cube, I said that the function is discontinuous at this point. It means that any value of x apart from x equal to minus cube root of 5 will make the denominator equal to 0. So we can do that from negative infinity to negative cube root of 5 union negative cube root of 5 to positive infinity. We can talk about this as the interval of discontinuity, meaning that the endpoints are not what? Included. Wow. And on the number line, there's an irrational number, so we cannot represent on the number line. And on the number line, yes, that's what. Okay, let's take that one. So that will be the interval of discontinuity. So that is it. This is the interval of continuity, not discontinuity. Now let's check this one. For this, let's equate the denominator to 0 and see. You have x to the power 4 minus 5 equal to 0. You have x to the power 4 equal to 5. Wow. And here you have x equal to the 4th root of 5. Very simple like that. And this is defined. Our 4th root of positive number will give us a real number. Wow. To give us a real number. So here, if the sign here is negative and we have an even power, we can equate the denominator to 0 and it will work. We will not do it as we did it here. So here, if the sign is negative, whether it is an even power or it's an odd power, we can equate it to 0. Let me repeat. If the number here, the exponent, if the sign here is negative, that one, whether the exponent is even or odd, there's no problem. But if the exponent is even and the sign is positive, then it is continuous everywhere. There's no need equating this to 0, and this will be the interval of continuity. But for now, we've equated this to 0 and had x equal to 4th root of 5. So here, we can say that any negative number up to 4th root of 5. This means that the 4th root of 5 is not included. Union 4th root of 5 is not included. Up to positive what? Infinity. So here, apart from 4th root of 5, any real number will make this function continuous. So at x equal to this 4th root of 5, this function is discontinuous. I hope you can put it together very well. Now, let's take another example. Ellie, you requested for the video, so I expect to read your comments at the comment section and then look at how best you've understood this lesson. If you are also watching, I expect your comment at the comment section. If the lesson has helped you, just leave it at the comment section. If you feel that there's some problems, you also leave it at the comment section so that it will improve me to do more accurate videos. Now, let's look at this one. Here we have 3x minus 1 divided by square root of 5x squared plus 2. Let us discuss the continuity of this function intuitively. Now, this is a rational function. So for rational function, our main aim is the denominator. So let's aim at the denominator. If you look at the denominator, we said that rational functions are not continuous if the denominator is equal to 0. And the denominator, we said that we have a square root here. We have a square root here. So we just look at what is under the square root. Wow. We are looking at what is under the square root. So if we take what is under the square root, we have 5x squared plus 2. We have 5x squared plus 2. And you see that if you put in any real number, you've done that one before. Because x is squared, any real number will give you a positive number. And this one can never be equal to 0. For real numbers, 5x squared plus 2 will never be equal to 0. Because if you equate this to 0, we are going to have x squared equal to minus 2 divided by 5. And then x will be equal to plus or minus the square root of negative 2 on 5. That will give us a complex number. And we are not talking about complex numbers here. We are talking about real numbers. So there's no need equating it to 0 to get complex numbers. So for real numbers, this function will not be equal to 0. So 3x minus 1 divided by square root of 5x squared plus 2 will always be defined or will always be continuous for real numbers. So the interval of continuity will be negative infinity to positive infinity. Very simple as that. So this function is continuous everywhere. It is continuous everywhere. Wow. I hope this one will help. Let's take another example. So you see this function is continuous everywhere. And the interval of continuity is negative infinity to positive infinity. Let's take another example. Let me take 7x squared minus 2 divided by square root of x minus 2. This is very simple. Now let's look at this one. What is inside the radical? If you take x minus 2 equal to 0, you have x equal to 2. Very simple as that. So if you put x equal to 2 here, we have 7 into bracket 2 square minus 2 divided by square root of 2 minus 2, 0. And that will give us 28 minus 2 divided by 0. And that will be undefined. And that will be undefined. That will be undefined. So it means that if we take the denominator x minus 2 to be equal to 0, you get x equal to 2. So this function is discontinuous at x equal to 2. Because at x equal to 2, the function will be what? Undefined. So there will be a hole in the graph of this function if x is equal to 2. So it is discontinuous at this point. Very simple as that. Now let's take the next example. The next example is this one. Now I did not state the point of discontinuity. Okay, it was 7x squared minus 2 divided by square root of x minus 2. So this function is continuous on this interval 2 to infinity. And it is discontinuous at x equal to 2. This is the interval of continuity. And this is the point at which the function is discontinuous. Now, why did I write 2 to infinity? I wrote this because you see that if you take the square root sign, numbers under the square root for it to be defined, then x minus 2 should be greater than or equal to 0. If this one is not greater than 0, we will get square root of negative number. And square root of negative number is a complex number. But we are dealing with real numbers. Very simple as that. So here, I cannot include negative numbers. So if I had written the interval to be negative infinity to 2, union 2 to infinity like this one will be wrong. Because here, if I take negative 1, or let me take values less than 2, let me take 1. If I take 1x equal to 1, I'm going to get square root of 1 minus 2. That will give me square root of negative 1, which is a complex number. Wow. So here the interval of continuity is all values greater than 2. This means that we are taking values greater than 2 to up to infinity. So we say x greater than 2. That will be the domain. So that's why we are saying that rational functions are continuous on their what? Domain. I'll do videos on domain of a function, but I've not done that. So let's continue. So the function in simple terms is discontinuous at x equal to 2, and this is the interval of continuity. Very simple as that. Yeah, Ali, it has left with one simple question, and then we will go away. And this is the simple question. I have 3x to the power 4 minus 2, 3x squared minus 5x plus 1, all divided by square root of 5x plus 3. Now you see that you can just equate this to 0. Let's do it and see. If we don't get a complex number, we go 5x plus 3 equal to 0, x equal to minus 3 on 5. So the function is discontinuous at x equal to minus 3 on 5. Because if you put x equal to minus 3 on 5, this one will be 0. Square root of 0 will make this function undefined. And there will be a breakage in the graph. So let us write the interval of continuity. So for the interval of continuity, you said that minus 3 on 5, comma, positive infinity. Remember, this is under the square root. So since it is under the square root, if we include any value less than negative 3 on 5, we will get a square root we will get a negative under the square root. Let's check and see. Let me take this. Minus 3 divided by 5 is minus 0.6. So it means that we have minus 0.7 here. So 0.7 is 7 out of 10 minus 0.6 will give us this. So if we take this one, minus 0.7, if we take 5 times minus 0.7 plus 3, minus 0.7 is less than this, minus 0.6. So let's take 5 times minus 0.7. That will give us minus 7 on 2 plus 3. So if we add it to 3, you will still get negative half. So if you take any number less than minus 3 on 5, have you seen? I converted minus 3 on 5 to decimals so that you look at how it is. So minus 3 on 5 in decimals is minus 0.6. And you see that minus 0.7 is less on the number line to the left. So if you put minus 0.7 here and you do this, you get negative half. And we can't take square root of that. So if we want the interval of continuity, we cannot include numbers less than this. For numbers less than this will give us square root of negative numbers, which will be complex and it is undefined and are real numbers. But any value greater than, that's why I've said that if you not watch my video on interval notation, check for it from the description. This means that we are taking values of x greater than minus 3 over 5. That is the meaning of this. Very, very simple as that. Thank you for watching, and subscribe to my channel. Thank you for watching. I am Mensa Augustine. Bye bye.